Okay, so I promised that I'm gonna make remake the lecture video on the first half of 1.3. So here it is. Example 1, find the GCF, or short for greatest common factor of the list number 8, 12, 36. Well, in 661 or 662, I use the prime factorization, right? So that means I'm gonna write out 8 is equal to 2 times 2 times 2. And then 12 is equal to 2 times 2 times 3. Basically, you break it down into the products of prime numbers. And then 36 is 2 times, 2 times 18, right? Which is 2, 18. So 2 times 3 times 3. Hold on. Yep. So the greatest common factor is the greatest number that divide all three numbers. So here you see these right here are the common factor of all three numbers, right? So the greatest common factor must be 4. Right? So here we say the GCF is 4. Okay. Similarly for GCF of 7a squared b and 14ab squared. So let's start out with the number first. Between 7 and 14, the greatest common factor is 7 because 7 divide both in 7 and 14. Between a squared and a, it'll be a. Between b and b squared, it'll be b. So 7ab. So this is just review from 62. Here is the step finding the GCF. I'm not going to read it for you. I'm just going to list it out there if you need to reread it. Right? But I'm going to jump straight to the examples. So I want you to factor 3y minus 15. This is an expression. So between 3y and 15, the greatest common factor is 3. So factor out with 3. So what's left? The first term is y's left, right? Because 3y divided by 3 is y. And then the second term is 5, because 3 times negative 5 is negative 15. And that'll be your final answer. Let's try number 2. Again, we're looking for the greatest common factor. Between 4, 8, and 28 will be 4, right? And then x. There's no y in the first term, so or the third term, so we ignore that. So it's gonna be what's left? It's gonna be x squared minus 2y minus 7. That's the leftover. Right? The leftover, you notice, by the way, I know many of you know this already, but in order to find the leftover, you take the original of each term, you divide it by the one that you factor out. Right? For example, 4x cubed divided by 4x is x squared. Right? Minus axy divided by 4x is minus 2y, etc. Okay, so I recommend you pause the video and try this on your own. I think I think I did that in the. No, I think I make that into a y x cube. Yeah, I make that into x cube. Okay, so I want you to factor this. If I was you, between negative 9, 6, and 21, I'm gonna factor out the negative 3. Oops, I'm gonna use red. And then x, there's no x in the last term, so we're not gonna factor out x. What about y? We can factor out a y, right? So let's see what's left in the first term is I factor out negative 3, so negative 9 divided by negative 3 is 3. X cubed still there. Y squared divided by y is y. And then minus, right? Be careful of the sign. When you factor out the negative, the sign change. 6 divided by negative 3 is negative 2. X squared is still there. Y divided by y is 1. We're not going to write it. Minus 21 divided by -3 is 7. And then y cubed divided by y is y squared. The notes here is that a lot of you kind of ignore the negative GCF. When you factor out GCF and if you're choosing the x to be a leading variable, here in this class, we're just gonna set a rule that x is always the leading variable. Okay, if I have x, y in the same expression, x is gonna be the leading variable. Therefore, if it have a negative coefficient, I want you to factor the negative out as well, right? So, what is the note here? When factor GCF always include the negative, I would say include -1 as well. All right, so that's factor out the GCF. The second section will be group factoring. Now, when do we use group factoring? We use this when you have 4 or more terms, right? The step will be, first you group terms with the common factors. So I'm gonna go through an example and explain it to you step by step. So I have xy plus 3y plus 2x plus 6. I'm gonna group terms with the common factor. So for me, I'm gonna group the first two and the last two like this. Now, some other student, they might group the first with the third term and then the second with the last. It doesn't matter, right? I think both will work at the same. You should have the same answer, right? As long as it's work, as long as it works. So here, what do I have? I'm gonna factor out a y for the first group. So I got x plus 3, and then I'm gonna factor out a 2 for the second group. So x plus 3 again. Make sure you have the same factor. You have to have the same factor. If you don't, something wrong. Rearrange the order again. So I'm gonna factor out the x plus 3 again. And what's left is y plus 2. So that will be your final answer. This one, I'm gonna play around a little bit. Normally for me, just to make it simple, I'm gonna factor out, I'm gonna group the first two and last two. Let's do that. I was gonna do first and third and second and last, but let's do first two and last two. So the first group, I'm gonna factor out a. What's left is x plus y. Second group, I'm gonna factor out -2. What's left is x plus y, right? Be careful the sign. Again, you have x plus y twice, so you factor that out. What's left is a minus 2. Make sure you have the same factor twice. You don't rearrange it or regroup it. Pause the video and then try number 3. Okay. All right, so I'm gonna group it like this. You can try the first two and last two, but I'm just gonna make some different. So first and third, I'm gonna factor out a y. What's left is 3x minus 5. Second and last, I'm gonna factor out a z, so positive z. Again, leading coefficient in x here. That means 3x minus 5 again. So we have 3x minus 5 twice. It's y plus z. The last section of the first half that we did in the first day we met is factor trinomial with the leading coefficient of 1. It has a form x squared plus bx plus c. This is the easiest one between the two. Remember, the second one is the leading coefficient is not 1. Okay. So of course, first you have to write it in descending order first. Write it in descending order. I wonder if oh, I wish I'd have took, I chose the wrong key, but that's okay. That's all right. Write in descending order, meaning it's the largest degree, and then you go in less and less as you move into the right direction. We're gonna use the AC method. We're gonna use the AC method. What does that mean? That mean I wanna, if I give you a trinomial like this, when I say trinomial, I mean it has three terms, three, right? The AC method say this, I want you to find me two numbers that the products, a lot of time I just denote P. The product is A times C. In this case, A is 1. So 1 times C is C. And then the sum is the middle coefficient B. Right, so this is AC method. Another method is called guess and check. And just a lot of students use this method, the guess and check methods for this kind of factoring trinomial when the leading coefficient is 1, right? Popular here. Is popular here. But when we go to the factoring trinomial with the leading coefficient is now 1, it's not quite popular, right? Okay, so for example, if I have let's see, if I have x plus 3 times x plus 2, you know, yes, times x plus 2. Let me move this down. So here I want you to FOIL it. So you FOIL it, right? Let's see. First, so x times x is x squared. X times 2 is 2x. X times 3 is 3x. And x times 3 times 2 is 6. Move to the left a little bit. And then you add like term. These are like terms, so you add them. So 2x plus 3x is 5x plus 6. Now, what if I give you, in the beginning, I want you to reverse engineer. If I give you x squared plus 5x plus 6, I want you to factor this. Okay, so this is factor. Let's see. I want you to find the sum. So we're going to use the AC method. I'm going to show you how to use the AC method. I want you to find the sum. I'm sorry, let's do the product first. So the product is to be C, right? Because here's 1 times C is C, 1 times 6 is 6, so 6. And then the sum is, let me do 1 times 6 just to make it into a good habit. 1 times 6 is 6. And then the sum is 5, the middle coefficient. What are the two numbers? 2 and 3, right? 2 and 3. You always start with the product first. So the product, the two numbers, sorry, two numbers multiply give you 6 is either 1 6 or 2 3, right? The 1 6 is not going to add up to 5. The 2 3 is add up to 5. So we pick 2 3. What we're going to do next is we're going to use 2 3 to split the 5x. So instead of writing 5x, I'm going to rewrite it as 2x plus 3x, and then plus 6. You can write 3x plus 2x. It doesn't matter the order. And then now we have 4 terms. We use group factoring, right? That's what we said. We use group factoring when you have 4 more terms. So you group the 2, group the 2. Now, it's not always the first 2 and the last 2, okay? The things that you have to group the one that have a common factor. So the first group, I factor out x. So what's left is x plus 2. The second group, I factor out 3. So what's left is x plus 2 again. And then you have x plus 2 twice. Factor out it again. What's left is x plus 3. times x plus 2. And that'll be your factor. All right, let's try number 1. Let's try number 1. So I want you to find me the sum. I'm sorry, I keep going with the sum first. Product is 10, right? So 1 times 10 is 10. And then the sum is 7. So the two numbers is 5 and 2, right? Or 2 and 5, doesn't matter. So what I'm going to do is I'm going to split that 7x into 2x plus 5x. Or 5x plus 2x, doesn't matter. So cx squared plus 5x plus 2x plus 10. Group factoring. For factor out the x for the first group, so I got x plus 5. Factor out the 2 for the second group. Then factor again. And then you can check your answer by forward it back. Okay. All right, let's try number 2. I'm going to try the guess and check methods for number 2. Guess and check method is pretty quick. So first, I need x and x, right? Because x times x is x squared. That's about it. It's always the 2 pairs of parentheses. And then the first thing first you do is put down x and x in each of the pair. And then I need 2 number multiplied is 24 add up to 11. Product is 24. Sum is 11. Product is 24. Sum is 11. All of a sudden I'm blank. A is in 3, right? So here it must be positive A and positive 3. It's your answer. Right? And then you can check x times x is x squared. I got 3x and I got ax, which is 11x. Yeah. And then the last one, 8 times 3 is 24. So it checked. Right? You can always check and erase that. Well, how many do I have here? All right, y squared minus 11y plus 28. So we're going to do the guess and check method. Like I said, it's popular for this kind of problem when the leading coefficient is 1. So y and y, because y times y is y squared. I need 2 number, product is 28, and the sum is negative 11. 7 and 4, right? Write out the number first. I'm sorry, let me say y. 7 and 4. I need negative 11, so both number has to be negative, right? Because when you add 2 negative numbers, still negative. But when you multiply 2 negative numbers, it becomes positive. So negative 7 and negative 4, you're done. That's called guess and check, right? Now you can check it on your own. I believe it's correct. Pause the video and try number 4 on your own. I recommend you pause the video, really pause it and just try yourself. The thing about factoring is a lot of practicing. And I promise you, you're going to see factoring as long as you're taking math courses. X and X, product is 8, sum is negative 6. So the 2 number is, I know 4 and 2, negative 4, negative 2. Right? So negative 4, oops, let me rewrite it properly. Negative 4, negative 2. That's it. We done number 4. All right. Let's try number 6 before we do number 5. I want you to find me 2 numbers. Product is 15 and sum is 9. Let's do the product first. For the product, what do I have? Either 1, 15, but it's not gonna make it into what? Into a 9, right? So I'm gonna cross that out. What about 3 and 5? Nope, 3, 5 does not make into a 9. So cross that out, and that's it. That's all your choices. So there is no, you cannot find two numbers that multiply give you 15 and add up to 9. So what do we say if we cannot factor? Well, one of the students said it's non-factorable. She correct. Right? She right. But here in math, we're gonna call it prime. It's like prime number. You cannot break it down any further. Right? All right, let's do number 5. Number 5, a little bit special. It's just slightly more special. Is because it has two variables, right? Before it looks like this. Before, what we usually do is like this. Maybe m squared minus m minus 12. But now it had n attached to the last two terms. So what we're gonna do is we're gonna ignore the n for now. Ignore the n for now, and I want you to factor m squared minus m minus 12 first. So let's do that. It's red. Okay, so here m and m, because m times m is m squared. And then I want you to find me two number multiply to negative 12 and add to negative 1. I see negative 4 and 3, right? Doesn't matter what order you put, negative 4 or 3, don't matter. You can do m plus 3 and then times m minus 4. Now remember, we kind of ignored the n before. Now we have to put it back. So where we're going to put it? We're going to put it next to the numbers. So we're going to put it back. I wish let me move the bracket a little bit, the parentheses a little bit bigger. Right here. Now you can check. Let's check. See if we have the right one. M times m is m squared. N times 3n is, let me do down here. N times 3n is 3mn. Negative 4n times m is negative 4mn, which is give me what? Negative mn, right? And then last one, negative 4n times 3n, which is negative 12n squared. So check. You erase that so I can box it. Number 7 similar to number 5, so I recommend number 7 and number 8. So I recommend you do it on your own. Pause it and do it on your own. So first we're gonna factor m squared minus 3m plus 12. We ignore the n for now, right? So two number multiply 12 add to negative 13. I see 12, 1, so minus, right? Negative 1 times negative 12 is positive 12. We add them together, we got negative 13. And now you plug in the n back. I keep forgetting. Let me put it in the way that I can put the n back. Did I say 1 and then 12? Now put the n back. That's it. That's all you do. Number 8, I'm not gonna talk, or maybe I'm gonna give you the answer so you can do on your own, okay? Pause recording.